All right, so we're going to do some gram-to-gram stoichiometry. So first things first, we have to balance the equation. Very most important thing in stoichiometry is balancing the equation. If you don't have the correctly balanced equation, then you're going to get the whole thing wrong because you won't have the right multiple ratio. So here's our equation right there. The balanced equation is 2, 7, 4, and 6. Okay, so that'll give us our mole-to-mole ratio when we are ready for it. All right, so letter A, using the equation above, how many grams of oxygen gas are needed to make 8.640 grams of water? All right, so we start with our given, 8.640 grams H2O over 1. Okay, so we are trying to convert grams of water into grams of oxygen. Okay, so we can't convert right from grams to water to grams of oxygen. So first, we have to convert grams of water into moles of water. So we put grams H2O on bottom, so that cancels out. We put moles H2O on top. 1 goes in front of moles, and the molar mass of water goes in front of grams, so that is 18.016. Okay, grams of H2O cancels out. We're left with moles of H2O, which is not where we want to be, so we need another conversion factor. Okay, so we want to cancel out moles of H2O, so we put moles H2O on bottom. Again, we are converting to grams of oxygen, so we can't go right from moles of H2O to grams of oxygen, so we have to go from moles of H2O to moles of oxygen. Okay, now this is our mole-to-mole ratio. Okay, so this is why it's important to balance the equation, because this is where that comes into play. So to get the numbers that go in front of our moles here in our mole-to-mole ratio, we look at the coefficients of H2O and O2. O2 is 7, which is right here. So we put a 7 in front of moles of O2. H2O is 6. So we put a 6 in front of moles of H2O. Okay? Now, moles H2O cancel out. We're left with moles of O2. That is still not where we want to be, so we need another conversion factor. Okay? We want to cancel out moles of O2, so we put moles O2 on bottom. Again, we are converting to grams of O2, so this time, since we're at moles of O2, we can go right to grams of O2. We put a 1 in front of moles. We put the molar mass of O2 in front of grams, which is 16 times 2, so 32.00. Moles of O2 cancels out. We're left with we're left with grams of oxygen, which is where we want to be. So now we do our math. So we take all our top numbers, so 8.640 times 1 times 7 times 32, and we get that for our top number, which is 1935.36. Don't worry about sig figs yet, because this is not our final answer. Just put the whole calculator answer. Okay, then we take our bottom numbers, so 1 times 18.06 times 6 times 1. 6 times 6 times 1, and we get 108.096. So we then go back to our top number, 1935.36, divided by our bottom number, which is 108.096, and we get 17.90408, blah, 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 blah. Okay, so now we got to do two things. Number one, we need sig figs. Okay, in our problem, we had 4 sig figs, so this number needs 4 sig figs. So it's going to turn out to be 17.90. And the number 2 thing we need to do is our units. The only unit that did not get canceled out is grams of oxygen. So that's what is going to be our unit, grams of O2. Okay, and there we go. That is how we do grams to grams.